The topic of the video lecture is an accelerated simulation of the thermal and mechanical reliability of electronic devices and circuits. Ladies and gentlemen, this is a Russian invention for your attention. An automized system of reliability and quality, assurance of equipment, Asonika. Maintenance of electronic equipment is characterized by an effect of the combination of severe external factors that simultaneously work, which leads to system failures. These failures are hard to find out during the course of the test, as there are no stands that simultaneously reproduce electronic functioning processes, concurrent thermal, mechanical, electromagnetic, radiation, and other exposures in an integrated manner. Asonika wasn't used here. The developer of the system is a research studies institute called Asonika. The system is about 40 years old. Its development started in the USSR. The system has many users in Russia, first of all an aerospace corporation, Energia. For almost 10 years, Asonika has been used in projecting electronic devices for the International Space Station. It's the only system used in Russia, and it's a monopolist here. This system was presented in the USA at Arizona State University, at a seminar in San Jose, and at a conference in San Diego, in India, in Delhi, and in Bangalore. In Russia, the USA, and India, there were no direct analogies of Asonika system found. Today, a scientific Asonika lab has been opened at a business incubator of Arizona State University. Dr. Alexander Shalamov is the Director General of the Research Institute, Asonika, and at the chair of the Information Technologies Department at the Russian Presidential Academy of National Economy and Public Administration. Dr. Shalamov has received several prestigious national awards in technology and recognized as a leader in the field of information technology, automated systems in Russia. He has more than 300 publications, including 10 books. During the last 10 years, he was the supervisor at 20 PhD works. The development of the Asonika system is performed as part of a scientific school of modeling, information technologies, and automated systems, NSMITAS, NS 5574-201410, in the branch of knowledge, military, and special technology. The director of the scientific school is the Director General of the Asonika Research Institute, Professor Shalamov A.S. The whole work of the scientific school, including the development of the Asonika system, is performed within margins of a virtual development laboratory, VDL, which considerably increases the effectiveness of the work. The work is performed at all times of the day, during holidays, and not depending on the location of the VDL workers. The director completely controls the activity of VDL in real-time mode. This scientific school has many achievements. One of the main achievements is the acknowledging of the Asonika system, the winner of the Russian Innovations Contest. The methodological basis for solving tasks at hand are ideas of mathematical theory, of modeling in fields and processes of various physical natures that correlate with one another in a single heterogeneous Earth. Models help to quickly solve the basic problem of providing and defined acceptable values of electronic currents and voltage, mechanical acceleration and voltage, temperature at every radio element and in every construction point. For example, for the temperature of a microchip in a circuit designed not to exceed an allowable temperature of 100 degrees Celsius, or for acceleration of a resistor not to be more than 40 grams. Models have the following advantages. They need little memory and time required for calculations, have small dimension, need little input data, give good coincidence with an experiment, are easy to understand, which is important for education. These models were developed by our research team. They are patented and checked in the course of many experiments. What is Asonika? Asonika is an automated software system for simulation of electronic devices, both for harmonic and random variations of single and multiple impacts, linear acceleration and acoustic noise, stationary and non-stationary thermal effects. The program calculates the number of the cycles to failure under mechanical loads, as well as under the cyclic thermal effects. Multiple approaches and models have been used to estimate reliability to predict potential sources of failure. Asonika is a substitution of electronics testing by a computer modeling for other heating, mechanical, electromagnetic, and other effects before its production. It's a considerable economy of funds and reduction of terms of equipment, creation with the simultaneous promotion of quality and reliability due to a reduction in numbers of tests. In the course of 40 years, we have been creating and have approved the breakthrough technology on many Russian enterprises, first of all in military, space, and aviation branches. The gist of the technology is the following. Using the developed Asonika system with the help of a computer, one can oversee and prevent all possible damages and overheating of the electronic equipment placed at military, space, and civil projects. All this can be done in the course of several hours and in a very obvious way. Here are some of the fragments of electronic equipment damages and overheats acquisition. Places of possible overheats and mechanical overloads are highlighted in red. Asonika was used here. Today the market is loaded with a quite ample quantity of programs, application program packages, and systems. Nastran, ASCA, Cosmos, ANSYS, Mars, MARC, etc. An analysis of the main characteristics of these programs shows that the best adapted for tasks of multiple survey and characteristics of electronics is the Asonika system because there are no enumerated drawbacks of programs that allow this needed effect. These drawbacks are listed in the following. 1. An observance of models and algorithms which take into account peculiarities of functional implementation and needed range of influence of stabilizing factors on the electronics output characteristics. 2. Because of an absence of specialized graphic interfaces for normal design implementation of electronics, implementation of normal design up to every electronic component of the computer needs much time in the required timescale. 3. Universal software packages demand special knowledge of an electronics developer in a sphere of mathematic modeling of mechanical processes, which it doesn't have in most cases. 4. The underlying models require much time in respect to electronics, from several hours to several days and months, calculation of every electronic component, optimization, dispersion. 5. Absent are databases with required geometrical and physical and mechanical parameters of electronic components and materials, allowing of many requires special research. 6. This complex is work training and requires more time, even for professionals. The Asonika system allows for the solving of three main problems existing in the course of modern electronic equipment development. A problem of possible breakdowns, prevention in the course of maintenance at early stages of designing. The problem of reduction of terms and costs for the designing. The problem of workflow optimization and creation of the model of electronics within limits of CALS technology. Let's consider the structure of the Asonika system. The structure assumes that in one process of designing on the basis of Asonika PDM system and with the use of the Asonika subsystem, the forming of an electronical model of the product occurs. In the upper part of the structure, widely used CAD systems are presented. Most of them are not Russian. They form output data for modeling in the Asonika system. First of all, they are PSpice, Mentor Graphics, Altium Designer, OrCAD, Pro Engineer, SolidWorks, Inventor, and Compass. In the middle, the converters of these CAD systems into the Asonika system are presented. In the lower part, there are subsystems of the Asonika system, creating the ability to model thermal, mechanical, fatigue, electromagnetic processes, create operation modes cards, calculate reliability taking into account real work modes of electronic components. In addition, a database of electronic components and materials required for modeling are integrated. Why is Asonika unique? 1. Asonika has reliable physical models and databases of the required properties and all materials and components. 2. Asonika has simple, intuitive interfaces that are easy to use by designers for rapid modeling. 3. Asonika considers features of properties of the materials applied in electronics, for example, their nonlinear properties. 4. Asonika is compatible with popular CAD systems and formats, PCAD, Mentor Graphics, OrCAD, Altium Designer. Asonika has been used by Russian companies and universities for more than 35 years. Asonika databases have been updated and new modules have been developed during the last 3 decades. How can Asonika help? Electronic devices are subjected to heat and mechanical stress. Failures can cause various problems ranging from an inconvenience to a catastrophe. Prediction of reliability within expected thermal and mechanical effects is mandatory for any manufacturing of any electronic device. There is a growing demand in software programs for rapid simulation, which can reliably predict potential problems, sources of failures, etc. Examples of modeling of a microchip in an Asonika M3D subsystem are presented. The subsystem allows the calculation of mechanical and thermal characteristics of microchips and blocks of electronics. The transient thermal and fatigue analysis in Asonika. a quarter symmetry model of PCB and BGA package. Specify initial temperature for the entire model, 20 degrees Celsius. This temperature will also be used as a reference temperature for thermal stress calculation. Select external surfaces and set the thermal condition, convection, and radiation from these surfaces to the environment. Specify film coefficient, emissivity, view factor, and ambient temperature values. Surfaces with thermal conditions become meshed. Symmetry planes should not have thermal conditions. Select the volume that represents the silicon chip and set it as a heat power source. For the transient thermal analysis heat power source, it can be time dependent. Input heat power versus time curve. In this example, 2 thermal cycles are modeled. Time-dependent heat power will cause cyclic temperatures and stresses. Cyclic thermal stresses are used for fatigue calculation. 1 thermal heat power cycle is a range of 8 to 18 watts, 2 to 4.5 watts for quarter symmetry model. Set material properties for all parts of the model. For solder balls, the following parameters will be used. Run automatic FE mesh generation procedure. Set solution parameters. Specify the end time of the analysis, the time integration step, and the number of thermal cycles contained in the solution interval. Temperature. Time curve at nodes. 2 arbitrary nodes were selected. Temperature versus time curves for the 2 nodes. Stress time curve. 2 arbitrary nodes were selected. Stress time curves for the 2 nodes. Fatigue plot. The plot shows minimum fatigue life, 451.9 thermal cycles, in the solder balls. Here are presented examples of the modeling of the thermal and mechanical processes of the INTE nanocircuit created at SolidWorks and converted into a Asonika M 3D subsystem where a model is automatically built. Mathematical models for analysis of the fatigue limit are presented. The subsystem of the analysis of the volumetric constructions of the electronic equipment on mechanical influences, Asonika M. On the slide, results of modeling of electronic blocks on physical impact are presented. They allow a developer to quickly make the decision of mechanical stability assurance, vibrations, bags, and linear accelerations. The subsystem is well approved in space and aviation electronics. Here, an example of construction modeling created in SolidWorks for the physical impact in Asonika M 3D is presented. In this case, a 3D model is converted and the model is automatically built in the Asonika M 3D subsystem. Subsystem of the analysis of thermal processes is Asonika T, an analysis of a stationary and non-stationary thermal regime of selected boxes. Blocks of equipment working at natural and forced convection in an air environment at normal as well as decreased pressure and an empty space in space conditions. There are interfaces for easier implementation of normal design. The Asonika T subsystem allows for the conducting of thermal calculation of any construction as well as non-electronic. This is its advantage. However, a user builds a thermal model of the construction himself on a computer screen. This model is easy to understand for those who know what thermal conductivity, convection, emission, sources of temperature, sources of voltage, sources of thermal capacity is. The Asonika TM subsystem is used for printed circuit boards. During the analysis of selected construction temperatures of separated isothermal volumes are defined in curves of temperature-time relationship for the non-stationary thermal modes are created. Models of thermal processes, Asonika T and Asonika TM. The structure is conditionally broken into elementary volumes by orthogonal planes A and the allocated set of elementary volumes along an axis X, B. A fragment of the electronic scheme, modeling of the non-stationary heat transfer processes through the elementary volume. Here is the modeling of boxes, racks, and blocks construction installed at vibrator isolators in case of an effect of vibrations, bangs, linear accelerations, acoustic noises. With the help of the Asonika B subsystem, it can be analyzed. The subsystem allows for the identification of the parameters of vibrator isolators, as well as the optimization of their parameters with an aim of construction load decrease. Here is a model for analysis of vibration isolation system presented. The subsystem of the analysis of constructions of printed board assemblies on thermal and mechanical influences, Asonika TM. As a result, one can get an acceleration and temperatures of all the electronic components in comparison with acceptable values. Models of mechanical processes. Asonika TM. A mechanical model of a printed circuit board. The Asonika UST subsystem is presented. The analysis of fatigue durability of designs of printed circuit boards and electronic components and mechanical influences. The Asonika EMC subsystem is presented. Electromagnetics compatibility, subsystem electronic and magnetic field intensity in the frequency range as well as screening efficiency. Asonika B is presented. Subsystem of the analysis of parameters of reliability taking into account actual operational modes. The Asonika B subsystem allows for the analyzing of boxes, blocks, printed circuit boards, electronic components, and solves the following problems. 1. Definition of reliability factors of all electronic components. 2. The statement of the need and evaluation of effectiveness of equipment backup, exploitation breakdown rates, the probability of serviceability, and an average non-failure operating time of equipment may be obtained as a result of the modeling. Reliability models. Asonika B. Integrated database of electronic components. Asonika BD. Asonika UM, the subsystem of modeling management during engineering. Asonika UM subsystem allows for the integration of CAD systems implemented in an enterprise, Pro Engineer, PCAD, Asonika, Compass, AutoCAD, PSpice, etc., and control data communication between subsystems while modeling in the process of construction designing of electronics. The subsystem is integrated with any PDM system used at an enterprise. In the course of projecting the subsystem, it allows for forming a complex electronic model of electronics within limits of mathematical models of thermal, electrical, electromagnetic, mechanical processes, and a mathematical model of reliability and quality of equipment. A great number of teaching guides and monographs is released. The latest books in the Asonika system are presented in Russian and English. The Asonika System Teachers of International Technologies Institute, India training. The Asonika System site in a business incubator of Arizona State University, the USA.